Good morning, and thank you for joining us for the presentation, What's New at Outback Power, brought to you by AE Solar and Outback. Before we begin, if you're experiencing any technical difficulties, please notify me by typing in your question in the question section of your control panel on the right side of the screen and click send. I'll go ahead and monitor that and see if we can correct anything that might come up. We will have a question and answer session following the presentation. You're welcome to submit your questions at any point during the webinar, and we'll do our best to answer as many as possible after the presentation. Any that we are unable to get to, we will respond to via email afterwards. There will be a brief survey that will pop up in a new window immediately following the webinar. Please take a couple of minutes to complete it, and we will email you a copy of the presentation. And if there are no questions, I'd like to introduce our presenter today, Mark Mays. Mark is Senior Applications Engineer at Outback Power. Mark, I'm passing the presentation to you.
Okay, thanks, James. Yeah, good morning, everybody, and welcome to all of the yous that work out of your house and those of you that are sheltering in place these days. So so welcome to this webinar. We have a fairly full agenda actually today, and I'll just cover that briefly. I'm stepping in for one of our field sales guys. Okay, so our agenda, we're going to talk about some market demands for storage. I'm sure you're well aware of a lot of those. We're going to talk about UL 9540 energy storage system requirements and what exactly that means. We're going to do just a quick overview of Radian and Skybox, just a couple slides on that for those of you that may not be familiar with those inverters. We're going to talk about AC versus DC coupling. What are the trade-offs on those? How would you do that with an Outback system? How you would do an AC or DC coupling retrofit with Outback. And then we're going to take a look at our latest energy storage lineup and what might be happening in the future. So again, this is probably going to be kind of a full hour, and I'm going to make myself available till about 10:15. We are doing our applications engineering group is just started something called Freeform Friday. It's going to be the last Friday of each month, and that starts at 10 o'clock. So I'm going to stay on as long as I need to about 10:15. If you don't have your questions answered for this one, you can always jump onto that webinar if you like. The link is on our website under webinars. So anyway, we'll go ahead and get started here. So there's been quite an increased demand for solar storage, and if you look at all the bars and graphs and everything that people have created, it's definitely up and to the right for storage, as opposed to solar only and net metering. So why storage? So from the customer perspective, avoiding time of use, peak rates, California, I assume most of you are on this webinar from California, but if not, time of use could be coming to utility near you. But for sure in California, all new solar applications require time of use rate structures, and really the only way with solar to make that viable is with energy storage. Most time use rates kick in around 4 o'clock in the afternoon, just when solar is starting to wane. So storage is probably one of the few viable, or the only viable solution you have. Backup power, a lot of people have been using our inverters for emergency backup power for quite some time. But now with both unplanned, which we never know is going to happen, obviously, but now we're also having planned public safety power shutdowns for up to a week, or in some cases even more. There's increased fire and flooding due to climate change. So we got a lot of new factors come into play that are pushing us towards solar plus storage. And also, storage can shorten the payback time, especially if you're doing some form of energy management like time of use, self-consumption, and also, future-proofing against future rate plans and rate structures that the utilities might be coming out with. So from the business standpoint, from your perspective, in terms of finding customers, it's reduced origination costs because you can call on your existing customers, referrals from jobs you did that had PV only, but now they want to add storage, maybe referrals from installers that don't do batteries. And so for us having energy storage system that's already pre-configured and put together. We have some simple to use sizing and selection tools. In fact, we just did a webinar yesterday on that. We're going to have a web-based version sizing tool for our SystemEdge packages as well that also has a string sizing tool. So you can not only size up a SystemEdge package for your application, but also has string sizing, so you can figure out what modules are going to work best with our gear. That's beyond the scope of this. If you want to know more, you can inquire at sales@outback.com or contact me. But it's a pretty cool, pretty easy to use tool. Also, we have pre-programmed configuration files, and so you can download those. Download the configuration files that are preset and pre-configured for that particular SystemEdge package. So some of you may or may not know that EnerSys battery company bought Outback about a year and a half ago, and they have world-class products and support just like Outback does. Outback's been around for 20 years, EnerSys for 100, and so our systems are still, battery agnostic, but with our energy storage systems, I think you're going to find that they're very cost competitive when we're packaging them all together from one supplier, and it takes some of the headache out for you also to get one solution from one place. Okay, UL 9540 and SystemEdge. So we're going to talk about energy storage systems and what that means, both from a UL perspective as well as what Outback can offer. So a UL 9540 energy storage system is comprised of a UL 1973 certified stationary battery pack, coupled with a UL 1741 certified inverter that's gone through rigorous thermal and electrical testing to make sure that the integration of a high performance system. So right now, UL 9540, or I should say the first iteration, only had to do with lithium batteries. So if you look at our IBR label right now, it lists the IBR 3-48175-LI. So these are the batteries with the SimpliPhi lithium battery, and it only applies to the SimpliPhi battery. Okay, it does not apply to all lithium batteries, only the SimpliPhi battery, and meets this UL 9540. Now we are in the process. Actually, UL came out with a 9540. I think it's the B version of it that includes lead acid batteries, because the first iteration did not. And the UL 1973 certification for batteries has been around. UL 1741 has been around for quite some time as well. But having the two married together, a specific inverter and a specific battery pack, gone through all the rigorous testing, is something new. And there's more to it than that as well. So in 2018, the California Building code adopted the International Residential Code, the IRC code, requiring a UL 9540 for an energy storage system. And one of the main reasons is this first bullet here: to eliminate poorly integrated custom systems that are unsafe or that underperform. And I'd say the vast majority of our installers do a really good job, and just need some assistance, maybe coming up with the final programming configuration or something like that. But I've also seen systems, both from on-site visits as well as people that sent pictures and configuration files, that were really a mess. And so one of the things that this is going to do is going to make sure that when a customer or a contractor specifies a UL 9540 ESS, that it's going to be tested together as a package. It's pre-wired, pre-configured, so that when you install it, it's going to work. Okay, and also having the UL stamp on the entire system is going to expedite your project permitting and approval as well. So these are just some of the proactive steps that we're taking, that really demonstrate our commitment to safety and performance for our systems. So this is a typical SystemEdge bundle, right? So we have, in this particular one, we have what we call our FlexPower Radian. So we have our Radian, our load center, it's all pre-wired. We have two FM 100 100 amp charge controllers that can have as much as 7,000 connected watts to each one. Our system controller, and all this is mounted onto a backplate. Kind of a heavy lift, but that is what we're calling an integrated flex power system. And then we have our Skybox inverter, which has all the PV solar charger integrated in, just like a grid tie inverter would. And we'll talk a little bit more about that. So it's either going to be a Skybox inverter or a flex power Radian. And we also have two flavors of the flex power Radian. We have a 4 kW with one charge controller, and we have an 8 kW, which has two power modules inside and two charge controllers, two of the FM 100 charge controllers. So I have two flavors of that in the Skybox. So those are your inverter options. Then we have either a 2-shelf or a 3-shelf, our integrated battery rack, our RBR. And this is showing, the SimpliPhi batteries. In addition to that, we have our 2017 rapid shutdown compliance solution. So in this case, this is an IMO Fire Raptor. This is the rapid shutdown initiator switch. Also has an internal power supply, and we do have a relay that is a DIN mount that would mount inside the load center here. And this will handle, and this is the Fire Raptor. It's not showing all the cords that come with it, but this little Fire Raptor module, it goes in series with the PV module. If you can have, this can handle up to 2 PV modules in series, as long as the temperature corrected voltage is less than 80 volts. And then, of course, what comes with all of our systems is the Optics RE remote monitoring and control system. So you can monitor and control the system remotely, along with event history for troubleshooting. Okay, so this is a single SKU package. So a single SKU for this. The only thing you have to add are some PV modules. So here we're showing the UL 9540 compliant. We have just this month, maybe into next month, we're going to start introducing our 9540 compliant lead acid versions of this with our other batteries, our PLR batteries and our Blue Plus batteries, which are a pure lead plus carbon. So so all of our SystemEdge packages are going to be UL 9540 compliant, if not already. Okay, so this is just showing some examples of what we have for our SystemEdge packages. And this is really, I can't can't emphasize enough as an application engineer. I've been with Outback for almost 10 years, and 90% of the problems I see when they get escalated up to me fall into one of three categories. One, it wasn't designed properly. Two, maybe it wasn't configured properly. Or three, maybe it wasn't sized properly. So the SystemEdge packages address all three of those issues: design, configuration, and sizing. So, it's really, and if you use our sizing tool with it, which has a load profile characteristic to it, and then it shows you what SystemEdge packages will match up with that load profile. Then you go into the string sizing tool, select your module. We have over 200 pre-configured, or you can put in a custom PV module, do your string sizing, and that's it. So you have one SystemEdge package SKU and then one SKU for your PV modules. And yeah, you have some other balance of system stuff you'll need to get as well. But the main cost and whatnot is going to be down to 2 SKUs, which will make presenting a bid to somebody very easy. Okay, so we're going to talk a little bit about Radian and Skybox, DC coupled systems, just kind of a little bit of review here. So when we talk about DC coupling, we're talking about how do we couple in the PV, right? So the PV goes through what we call a charge controller, or a solar charger, if you will. It's a DC to DC converter that regulates the variable DC up on the array into a highly regulated DC for the battery charging. Once the batteries are full, that gets passed into the inverter, which converts over to AC into a backup loads panel. So a lot of the loads, the important loads, get moved over to a backup load panel, and so anything that is left over from battery charging comes to the backup load panel, goes over to the main service panel. If anything's still left over, then it goes on out to the grid if you have a net metering agreement. So the main difference is, Skybox has this DC to DC converter inside of it. Okay, so looking at the Skybox, it's got a 5-port design. So the grid is bidirectional, so grid power can come in and power loads directly. It can be used to charge the batteries. The batteries can be used to power loads. The PV power can be used to charge batteries. It can be used to power loads. It can be used to export to the grid. And then we have a generator port as well. And we also, with our latest version of software, I believe it's 1.4.5, now supports AC coupling, which we'll talk a little bit more just momentarily. So we have this 5-port design. It's not a bidirectional H bridge like our inverters and many of our competitors' inverters are. It's got some pretty sophisticated power flow management inside of it. Okay, one of the things that is really critical when you're looking at solar plus storage, and you want to do kind of like an apples to apples comparison, it's best if you can take the storage component and come up with something called levelized cost of energy. So what it does, it converts the total battery cost to cost per cycle, provides an apples to apples comparison of energy costs between the batteries and the grid, or any other alternative energy source that you want to compare it to. So when you enter the data into Skybox, you'll put in the utility rate, the cost of the battery bank as levelized cost of energy, the depth of discharge, and then from that point, Skybox will decide whether the grid or the battery is cheaper at any point in time when not drawing from PV, because it's always going to assume that PV is going to be the best use. So if you can use PV to power your loads and then secondarily charge the batteries, that's going to be the most cost-effective use of PV. So the formula for determining levelized cost of energy, so this is a little converter. If your batteries are specified in amp hours, which most lead acids are typically in an amp hour, most lithiums, however, are already in kWh. So this is a kWh converter. So you take the amp hours times the battery voltage divided by 1,000, and that will give you kilowatt hours. And then the next part in our formula is the battery efficiency. So 0.95 is our battery efficiency times the number of cycles at the depth of discharge we're going to use for those batteries. So if we multiply that together, divide that into the cost of the batteries, that gives us a levelized cost of energy, which in this case is 26 cents a kilowatt hour. So now you have a measurement that says, okay, for example, let's say we're in a time of use application where you know the energy during the low use is maybe in the say 24 cents or 28 cents a kilowatt hour. And then all of a sudden when you hit you know, 4 o'clock in the afternoon, that rate jumps up to 54 cents. So now, rather than paying, you know, 54 cents a kilowatt hour, now we're going to disconnect from the grid. We're going to use, at 4 o'clock, we'll still have a little bit of PV energy. So we're going to blend what we can off our array with the battery energy, power our loads until, let's say, 9 o'clock. And then at that point, the rate changes again. And then we'll evaluate whether, say, it was 28 cents, maybe it's still cheaper to run off the batteries. But at midnight, let's say that rate changes to 18 cents a kilowatt hour. Now the grid's actually going to be cheaper than the batteries. So at this point, say from midnight till 6 in the morning, we're actually going to run off the grid because that's our cheapest way to do that. So this is kind of how levelized cost of energy is used internally, but also when you're comparing different storage solutions, different battery types, different chemistries, the best way is to reduce each one down to this levelized cost of energy using this formula, and that way you can see, you know, which is most cost effective. Okay, so just kind of comparing the two inverters, the FP Radian, we have a 4 and an 8 kW version. The only difference on the 4 kW, it's missing a power module inside. Skybox is 5 kVA. Surge power, we have really good surge power with the Radian inverter. It makes a really good off-grid with well pumps and that sort of thing. Skybox does not have any reserve surge power at all, so you'll need to factor in any surge along with that, or you'll need to find a way to deal with the surge like a soft start or a variable frequency drive or something like that. Time use support, we do have, with the Radian, we do have grid use timers, but it's not doing any levelized cost of energy comparison, so it's kind of basic. You can program it to go offline during that like 4 to 9, but after that, it's just, it doesn't have the advanced evaluation and power flow management that the Skybox has. In terms of self-consumption, it's pretty much limited to the backup panel, especially if you're in a place where you're not allowed to export to the grid. With Skybox, it has an external CT that can go on the utility side of the main service panel, and it can check and make sure that nothing's being exported. So not only your backup panel is being used for self-consumption, but the main service panel as well. In terms of location, the Radian is indoor rated. Skybox is NEMA 3R. Although I don't know that I would put the Skybox, you can mount it outside, but I'd probably mount it under an eave or something. I don't know if I'd put it in direct rain, but it is rated for that. Okay, in terms of integrated PV, you can have up to 7 kW of connected PV to the FM100. So it is limited to 100 amps. So it's 100 amps times whatever your battery voltage is. So if you're charging at 57 volts, that's going to be 5,700 watts. If you're, you know, equalizing at a higher voltage, you'll see more power come out of it. But just keep in mind, it's 100 amps times whatever your battery voltage. That's what you're going to get out of it. The Skybox, you can have up to 6.5 kW connected at 600 volts. There's two PV inputs, but they're parallel inputs. So it's like two strings of 600 volts, but it's a single MPPT. we recommend the Radian for off-grid applications, but not for the Skybox. It's really designed for energy management. It doesn't have surge capability. It's designed to be connected to the internet. So it's really more of a grid-connected, grid management type of an inverter. Okay, so now we're going to talk a little about AC and DC coupling. So one of the first options is we're going to talk about is a retrofit option. You can see this is the balance of system load center portion of the Skybox inverter. And if you've ever installed a Radian, you can see this is a little bit cleaner installation, a little bit easier. This is the PV side. So these are the two PV inputs. This is the disconnect where these two inputs get combined into a single one, and then that comes up here through this little current sense into the inverter. Okay, so we're talking about retrofitting for AC coupling. So if we're going to replace the okay, so we're looking at replacing the grid tie inverter with a Skybox. So with the Skybox, it can handle 600 volt array. So if you have a 600 volt array with your grid tie inverter, you could just drop in a Skybox quite easily. You would still have to put in the a backup loads panel, critical loads panel. I have to move some of those critical loads over to the backup loads panel, drop in some batteries, and that's pretty much it. So it's a fairly easy thing to do, especially if if it's an older inverter. This will allow you to still take use of an existing array. Okay, and I already talked a little bit about rapid shutdown. I want to just mention a couple more things about that. There is an application note that we wrote about the different options we have for rapid shutdown. So it's just a switch and a relay, or our RSI switch, and a 24 volt power supply, a little dim out power supply. So our rapid shutdown solutions are much easier than they were when we had the 2014 ICS Plus box solution. So our rapid shutdown solutions are much simpler than they were before, and very easy to implement. Okay, with Radian, we do have a 300 volt limit on the charge controller. So if you have a 600 volt array, you may have to rewire that array a little bit, but then you're going to drop in the batteries just like you did with Skybox, and then you're going to have to put in the charge controller along with the Radian. Okay, so again, this is if you're doing drop-in replacements for the grid tie inverter. Okay, so again, we have 8 kW or 4 kW, strings up to 6. Working with our string sizing tool, most modules like 350 watts or more are going to be like a 5 in series rather than 6 in series. But again, you can figure that out with our string sizing tool. Could be that maybe you leave some of the PV connected to the grid tie inverter, just leave that in place, and then move some of the strings over. And so you just drop in your flex power Radian, some batteries, and move some of that PV over. Okay. Option 2 is AC coupling. So just kind of review, a standard, grid tie inverter system or grid dependent system is just going to have the array sized up, the inverter sized up to whatever the array is. That's going to invert into AC. It's going to get self-consumed at the main service panel. Anything that's extra is exported if you have a net metering agreement. So the problem is when the grid goes out, this system can't operate. Even if there's sun out there, it can't operate because it needs to have the grid to connect to synchronize to. Okay, so when we AC couple, and the reason we call this AC coupling is we're taking the AC output of the grid tie inverter, and rather than connecting it directly into here to the main service panel, we're basically putting our inverter in series. So when we're grid connected, our inverter basically is acting like a piece of copper wire. Our transfer relay is closed. The AC input, AC output are connected through a relay. So again, we're just a copper connection right here. It's almost like we don't exist, right? Except that you have installed a backup load panel for critical loads that need to be backed up, and you've added some batteries. Okay, but other than that, we're just in series. When we're grid connected, it's just like the grid tie inverters hooked in right into the main service panel like it was before. Okay. So when the grid or when the sun goes down, there's no PV, then we will go ahead and pass that. We're still in the pass-through mode. We're passing energy on over to the backup loads panel, and we're working just like, again, we're still like a piece of copper wire at this point. We're charging batteries. And I also want to mention also in this scenario also, there's power that's coming through the inverter. If the batteries need charging, they can also grab some of that renewable energy. So they're not charging from the grid. They are being charged from the grid tie inverter. Okay. So now when there is a grid loss, that transfer relay opens up inside, so the AC input and output are no longer connected, so they're completely isolated. We're islanded here, if you will. And now we become the new grid source for the grid tie inverter to synchronize to. So it's synchronized to our inverter. Any PV production that comes out as AC energy will be used to power these backed up loads. If there's energy left over, that's going to come in and it's going to go as an unregulated charge onto the batteries. If the batteries get too full, then we'll start shifting our frequency up to the point of 60.5 hertz. If this is an old UL 1547, IEEE 1547 inverter, it's going to just shut off at 60.5 hertz. If it is a UL 1741 SA compliant inverter that has grid support functionality to it, as we increase the frequency in California Rule 21 up to 62 hertz, it will start curtailing its output, which will keep our battery from getting overcharged. Okay, so we use this frequency watt functionality of the 1741 SA, and we'll just keep cruising along here. Now, if for some reason the PV array cannot meet load requirement, then we will blend our AC energy with the AC energy coming out of the grid dependent inverter, and they will blend together to power these loads. And then in the evening time with PV loss, then we will power the loads completely from batteries, and then repeats the next day. So that's kind of in a nutshell how AC coupling is going to work. So with the Radian version of this, it incrementally steps up the output frequency, as I said. The firmware you can download from our website, and it's just going to use the target battery voltage and current limit, which are programmable to do its thing. So it's going to increase its frequency when the charging voltage target is exceeded by more than 0.4 volts. So if we're getting that unregulated charge back onto our batteries, and our current charge target is, say, 57.6, at 58 volts, we'll start shifting frequency. And it's super fast. It's super fast. I mean, it'll get up to 60.5 in the blink of an eye, and shut down that inverter. So there's very, very little chance of the batteries getting too much voltage. We also have AC charge current limit. So this is new for us, and I know some of our competitors don't offer this either. So when the AC charge current limit setting is exceeded, we will also increase the frequency. So we're protecting the battery bank on both battery and current. And so with UL 1741 SA compliant inverters, which most newer inverters are back to 2018 or so, they will modulate their output as the frequency rises. So they're not going to just get kicked off at 60.5. They're already going to start modulating their output as the frequency goes up. It's going to go down. So I've done a lot of testing with this, and so when you go down to a really load level, so there's a lot of extra energy coming from the grid dependent inverter, this frequency watt modulation technique works pretty well. It's not as well regulated as when you're DC coupled, and we can control more precisely, but for emergency backup, which is what I recommend for AC coupling, I do not under any circumstance recommend AC coupling full time. It's without the really tight regulation, it's going to be hard on your batteries over time. So if you're just doing it a few weeks out of the year, yeah, probably no big thing. But I do not recommend AC coupling like on a daily basis. I know some people have done some new installations. It's more efficient to grid tie inverters more efficient. And we'll talk a little bit more about that, but it really isn't when you're charging batteries in an AC coupling application. It's actually worse. So I'll talk about that more in a moment. Okay, so AC coupling with Skybox basically works the same thing. Oh, I wanted to mention with Radian, this is, we can connect up to a 7.6 kW now. We used to have a 6 kW limit. Now that limit is 7.6 kW, okay, because we can respond much quicker. The previous 6 kW limit had nothing to do with protecting our inverter. It was there to protect the battery bank because we were using a blackout relay, which didn't always respond as quickly as we would have liked. Okay, so Skybox AC coupling can produce 5 kW power. Okay, so it's compatible with older GT inverters like the IEEE 1547, the UL 1741 non-SA inverters, up to 5 kW nameplate, or up to 7.6 kW grid tie inverters that meet the 2018 or later UL 1741 SA requirement. And that's when we use that frequency watt technique. As we increase our frequency, we can curtail this. Because if you try and put more than 5 kW through the inverter, it is going to error out on an overload. So, but we've done some testing with this. As long as we can curtail that inverter when it starts approaching 5 kW, then we can curtail it. And usually a 7.6 kW inverter is rarely working that high anyway. So, but so you can connect it, but it will curtail above 5 kW. There's optional external CT, which I've already talked about. So when you're grid connected, you can take advantage of some self-consumption options. Okay, so comparing them, AC coupling, continuous power for the Radian, up to 7.6 kW. With the Skybox, you can connect to a 7.6 kW as long as it's UL 1741 SA, so we can curtail it if it ever exceeds 5 kW. Otherwise, the limit's 5 kW. The maximum battery charge power is 7.6 and 5 kW with the Skybox. They both do frequency shift and protect on voltage and amps, over voltage, over current. Time of use without grid charging. So one of the things in California, I don't know if any of you are involved with any of these S-chip grants or whatnot, but and I think there's also some utilities are starting to come out with some restrictions about charging batteries from the grid. So So if you're doing this time of use and you have our Radian in series, we cannot guarantee that it won't charge the batteries from the grid. However, with Skybox, we can. So if that is a requirement to not charge batteries from the grid, Skybox would probably be the better one. Skybox does another thing that's really cool too. If you, let's say you had a 7.6 kW grid tie inverter, you could move 2.6 of that over to the DC input of the Skybox and keep 5 kW AC coupled. And that's kind of cool because if you do start reaching that total limit of above 5 kW, it will curtail the DC input first before it starts to curtail the AC coupled portion with the frequency watt function. So it's pretty cool that way. I wouldn't recommend AC and DC coupling with a Radian. They're independent functions. The solar charge controller works independently of the Radian. It's not coordinated, and do not recommend it. So yeah, but stackable, that could be a limit with Skybox. We can only do a single inverter, AC coupled. We support up to 3 Radians. I've heard of people going more than that, but we support up to 3, and they both work well with generators. The Radian has a generator protection relay. The Skybox detects if the generator is being backfed and will open up the port. So we do have protection for generators. So we have some pre-bundled packages. Skybox, there's nothing special in terms of hardware. It's just, it's just the same thing. It's just what you buy with Skybox is all you need for AC coupling. With the Radian, you have everything that you get here. And now we have SystemEdge package. It's brand new. We're just people listening here. It's on a special price list, and it's only with SimpliPhi batteries. It's with 3 SimpliPhi batteries. You can add more if you want, but it's a really really nicely discounted, very cost-effective system if you're going to use Radian for AC coupling. So it comes with the load center. You still have to attach the load center, land your field wires, generator protection relay if you need it. 30 amp disconnect you can put in here if you want to have a disconnect for your grid tie inverter, because it's probably outside. The Radian will be inside. You get the Mate 3S system controller, which is also your gateway for Optics RE. And so you can order like this, or if you want a SystemEdge package, there's a new SystemEdge part number. I forget what it is off the top of my head, but just letting you know that it's brand new and does exist. So AC coupling, again, as I mentioned, AC coupling, because, and this is true with anybody's AC coupled system, it's never going to regulate it with the charging voltage to the batteries within a couple tenths of a volt. Nobody's solution does that. Now, with frequency watt, that we do much better regulation, but it's still not going to be. And if you're only doing it, like say a couple days, couple weeks a year, is no big thing. But I would never recommend using AC coupling for daily cycling of the batteries, daily cycling and charging. Okay, so one advantage though to AC coupling is you can make use of the existing hardware. You just add our inverter, set of batteries, and just leave everything else intact. So it's a lot less disruptive. You don't have to spend a lot of time on the roof. Now, when you're grid connected, the grid tie inverter efficiency is not impacted. Again, like I said, we're just a piece of wire, between the grid tie inverter and the grid. However, when you're DC coupling, you're going to get much more efficient battery charging than AC coupled PV charging. So when you are in off-grid mode, if you will, when the grid is out, you're going to get much more efficient battery charging when you're DC coupled. Also, if you're going to be doing energy management, highly recommend DC coupled system if you're going to use like time of use, self-consumption. It's really going to be much better. The generator integration is more simple, although with Skybox it's kind of transparent really. But so that's basically the main differences between AC and DC coupling. Yeah, retrofitting AC coupling can make more sense. If it's a brand new system, I definitely recommend going DC coupling. Okay, so now we're going to switch over to our energy storage lineup. We'll pretty much conclude the session today. So we have the PLR, which is a thin plate pure lead battery. Thin plate pure lead has some pretty interesting characteristics to it. One is it can, because of more surface area, can dissipate heat, so you can take a lot of pretty high charge rate on it. The temperature rating is extended, has an 18-month shelf life, so the self-discharge is really low on a pure lead battery, super low. So there's very little parasitic load on it. So it's just really, really pretty good technology. And these can have like a 15-year standby life. Only thing about the pure lead, it only has 1,500 cycles at 50% depth of discharge, which, on older AGM technology, this is actually pretty competitive. But do keep this in mind. In fact, the other thing too, I'd say is if you are in if your customer just wants to do net metering and just have emergency backup power, I definitely recommend the PLR battery for that, because it does have a long standby life, low self-discharge. And at 80% depth of discharge, this drops down to 675. But if you're only going to discharge your batteries, few days, few weeks out of the year, it doesn't matter. So I would also, would put the low battery cutout down to about 80% of capacity in this application. That's going to give you more capacity as well. It's going to drop your cycle life to 675, but again, it's going to still give you more cycles than the battery's going to last anyway. So this would be for emergency backup applications. The Blue Plus, again, it's the thin plate pure lead, but it also has carbon, and the carbon discourages it's at the negative plate, so it increases power and it reduces the sulfation. And the other thing that's cool about that is it likes the partial state of charge. So if it doesn't get fully charged all the time, it's not only a penalty, can actually increase cycle life. So it really likes partial state of charging. They do not, if you go below 50% depth of discharge, you are going to start losing cycle life though. So you want to keep it between that 50 and 100%. It's got 2,050 cycles at 50% depth of discharge. If you're going to use our battery rack, the 190 is the largest that you can do, and that 190 is equivalent capacity to a 200 amp hour battery. If you go to the 210 amp hour size, that will not fit. So all other sizes will fit into our battery rack except the very largest 210. And so if you look at the temperature spec down here towards the bottom, minus 40 F to 150 F. So that's a pretty broad range. Now, just to keep in mind, you are going to, when you are, even though it's rated at that, if you're consistently charging and discharging at high temperatures, that is going to reduce cycle life on any battery. But it does have that higher operating range and lower operating range because of this thin plate pure lead technology. Other thing I wanted to mention about these two batteries, the PLR and the Blue Plus, there is effectively no charge limit to them. I know we do have a rating on there, but they basically, they have, as you push more energy through them, they will self-curtail that charging current. And almost all lead acid batteries do not have that capability. And where this is important is in applications where you're big on solar and small on batteries, because batteries are the most expensive part of the system. So some people say, well, I'd rather go big on solar, self-consume, net meter the rest of the utility, and just have a couple strings of batteries. What's nice about PLR and Blue Plus is you don't have to worry about overcharging the batteries. Okay, as compared to like the SimpliPhi batteries, the lithium SimpliPhis, there is a formula in our application note as well as the integration guide from SimpliPhi that specifies a minimum number of batteries for a given charging source. In other words, you can overcharge the SimpliPhis if you have too much solar. So that's something to keep in mind between these batteries. Okay, we do have the RE battery, which has been around a long time. These are 2-volt cells up to 2,700 amp hours, so you can go pretty big on these batteries. 1,800 cycles at 50% depth of discharge, so they're kind of between the PLR and the Blue Plus in terms of cycles at 50%. They're designed to be on a kind of a flow battery. They do okay on cycling. And if you oversize these batteries to your application a little bit, like only discharge down to like between 30 and 40%, then that cycle life will go up. Something to think about. This battery here is an interesting battery, the XLC battery. So this battery has 3,800 cycles at 50% depth of discharge. And it's about well, it says 1,220 amp hours at C100. It's right around 1,000 amp hours at a C20. 17-year service life at 25 C. So if you maintain that room temperature, you have a very long service life. They do have it's lead acid, AGM plus carbon. So that's what gives it that high cycle life. And that includes a steel cabinet. So there's a steel cabinet, and it's this modular design. So, excuse me, it comes with like one of these rows of batteries. So it comes like this one will come in 4 stacks. You stack them on top of each other, and then you have these little interconnection bars between the different stacks. So it can go together a little bit faster if you have a way to lift the weight. So if we do a cost of ownership, excuse me, between this XLC battery, the SimpliPhi, and say Discover, this is that levelized cost of energy, the cost a kilowatt delivered. So XLC is 16 cents a kilowatt. The only levelized cost of energy battery I think we've seen better than that is the LG Chem lithium battery, which is kind of hard to get these days. But it's got a very good, even compared to the cycles of the SimpliPhi, because the technology per watt per kWh is less. So something to think about. XLC is a very cost-effective battery. Okay, so what's next? So EnerSys, excuse me, has already been doing making some advancements in lithium in their what they call their motive power, which is primarily forklifts. EnerSys has a huge market lead in the forklift battery market. Also, they have some telecom style UPS backup, standard telecom rack size solutions. EnerSys is coming up with a custom-made rack for Outback that's kind of to go along with our new kind of Skybox industrial design that we're calling Orion. So mechanically, if you look at this, it's about 380 to 400 pounds. Compare that to an IBR3 with 12 of our, our 3-shelf rack with 12 200 PLR batteries, 670 pounds versus 400. Even 6 of the SimpliPhis is another 150 pounds. So it's going to be a very the power to weight ratio is going to be very good. These little access glands can be moved to either side. It's going to have a RJ45 CAN bus, active cooling, some LED status, and it's designed for floor standing. One thing, so there is some kind of a building block architecture. So the BMS is going to go on the top shelf, and then you can either put 3 or 4 of these 3.7 kWh power packs inside of these. And of course, you can put these different packs in parallel. Right now, this is only going to be working with our Skybox, the Orion, plus any future inverters that we come out with. It does need that CAN bus to work with the BMS and this kind of lithium technology. Testing's currently underway. We should, I believe the target is to have this introduced before the end of the year. And there is a new price list. We have some webinars. As I mentioned, check our webinar website. We had offered this Power California workshop. It's our SystemEdge UL 9540 energy storage system workshop. We've been doing those as like a 6-7 hour workshop we did in January and February in California. We're moving that onto the web the week, I believe, of April 20th. We're going to do it in 3 parts, like a Monday, Wednesday, Friday. It's good for 6 NABCEP hours, and we'll show you how to use the tool, the selection tool, and also, we're going to do this Freeform Friday, the last Friday of the month. You'll be able to just kind of an open forum, with Outback's application engineering group. And so, yeah, that, and we have some like NEC 2017 rapid shutdown webinars coming up. So keep an eye on our webinar schedule. We got a lot of stuff if everybody's still kind of sheltered in place or limited mobility. You can still learn with Outback and get your NABCEP credits and go from there. Okay, so with that, I want to thank you for your time. Turn this back over to James, and thank you for your time and attention.
Thanks a lot, Mark. I appreciate it. Yeah, so we'll go ahead and start off our Q&A session now. If you have any questions, please submit through the questions section located on the control panel, and we'll try to answer as many questions as possible. There are some questions that are already submitted, so we'll go through those. And you can exit the webinar at any time during the Q&A session, and the survey will pop up in a new window once the webinar ends. Give us your feedback on the survey, and we'll send you the presentation. So the first question I see here from Dennis is, does your SimpliPhi battery have altitude limit?
Oh, that's a good question. That's a specification I have not seen. You'll have to ask SimpliPhi on that one. I don't know the answer.
Okay, and then we have one from Bill. The FM100 has capability of 2 PV strings input. Can they each be different VMPP and amps?
Okay, so the Skybox has 2 different PV inputs. The FM100 only has a single PV input.
And on the Skybox, would they be able to have those strings be different?
No, they have to be, so they'd have to be essentially off the same array. So two strings off the same array. So they get combined internally. It's a single MPPT on Skybox.
Gotcha. Same person, Bill is asking, with a pre-bundle system like Radian and SimpliPhi, does System F100 come pre-programmed to properly play with the batteries?
Yeah, it doesn't come pre-programmed, but there is a configuration file that you'll be able to download from our website, and you'll be able to load that. So that's going to cover all the battery settings. If you have like a particular input mode that you want to use, then you'll need to configure that. And anything that's AC coupled on the Radian, that is a special firmware version, and you'll need to download that firmware version. So it will not ship pre-configured.
And Bill's got one other question here. Pre-bundled system warranty for total system, does it vary for batteries?
Yes, the the batteries do have different warranties. Um, and it kind of depends, like SimpliPhi, they warranty their batteries on number of cycles. And I actually think that that's really the way the industry is going to head at some point. Right now, our AGM lead acid batteries are warranted in years, and so I think it's a 3-year on the Blue Plus and the PLR. The XLC battery that has a 10-year warranty if you monitor using Optics RE. Otherwise, it's 7 years. And so, yeah, the battery warranty is gonna vary. Otherwise, it's our standard. All the other equipment is their standard 5-year warranty, but you can get an extended 10-year warranty.
Oh, interesting. So you expect that the industry on the battery side is going to move to cycle time or amount of cycles versus years?
Yeah, I really think that's kind of the way it's heading. I know, especially with lithium batteries, that's kind of how most manufacturers are doing that. I expect that lead acid will probably move that direction also. It's kind of hard to say because really the years really, I mean, it really depends on, it's so hard to gauge because other things affect it, like temperature and that sort of thing as well. So I don't know if we'll move that way with AGMs, but for sure lithium is heading that way.
Yeah. And then I've got another one here from Tom. Are there plans to make the Orion compatible with the Radian? We need a lot more power than the Skybox can give.
Yeah, so if you want to have lithium batteries with Radian, you're going to have to go with SimpliPhi. I don't know if EnerSys is going to have like something, like the lithium iron phosphate technology, because the lithium technology is not lithium iron phosphate, and so it does require closed loop control between the inverter and the battery pack, and that's not something that you can do with Radian at this point. But we are going to be coming out with some new inverters the next year or two that will be Radian-like, if you will, and that we'll be able to work with those kind of batteries. Have a CAN bus and be able to do closed loop control with the battery pack. So right now with Radian, it's going to be pretty much like the SimpliPhi, lithium iron phosphate category battery and the AGM lead acids.
All right, excellent. Well, that is it for questions. There's none others that are coming through. Mark, I'd like to thank you. Mark, do you have any final comments before we close up today?
No, just thanks for allowing us to participate with you. AE is a great partner with us and for years, and you guys have great support for us and your customers. So happy to join you today.
Yeah, thank you. We appreciate it as well. And to everyone out there listening, we appreciate your business. And I know we're going through unprecedented times right now, but we're here and we're open to help you. You know, we're still delivering, and our team, we're all working from home, but our tech team, they're still here, ready to help you with any system designs that you might need. So please don't hesitate to reach out to us. And everybody stay safe. And thank you so much for attending. We appreciate it.